Hey guys. So today we're going to be doing a little bit different tutorial. And as I mentioned, it's just for the premium subscribers on Patreon. Um, this is one of my all-time favorite algorithms and things to play with. I've been working with it for quite a long time, and the one that we're looking at now is the current iteration that I use in a lot of projects. So I'm not going to walk through how to actually construct this component, but I am going to walk through how to use it and how I generally integrate it in a couple different setups to do some cool things and hopefully spark some ideas. And of course, I will leave the component in here as well, so you guys will just have that to play with. Before I go on, I should say that it learned the original tutorial here from Bruno on YouTube. His fluid simulation is what I based mine on. So if anybody was interested in the actual underlying, I'm going to do a tutorial on it as well at some point, because I do think there are some different ways to go about it at this point after I've done some research on my own, but I do want to call it out because this is a phenomenal resource, and I originally was able to build this myself. So I'll put the link in the description, but wanted to just call that out at the beginning. So with that said, let's get into things. Yeah, so I was just looking at something, but we'll do that later. So let's first just look at our simulation by itself and just kind of walk through what's going on here. So we have a fluid simulation. A fluid simulation is simply a numerical solver that's going to take a bunch of different steps. Steps are represented as GLSL shaders. And it's going to calculate each step using input and output textures. So this is the actual simulation. Like I said, I'm not going to really go into what's going on here at a deep level, but I do think it's helpful to have some sense of what the steps are, so that you can know how to use it in different ways. So with that said, we'll kind of walk through the simulation, and I'm just going to give a high-level overview and not get too technical. So first texture that we're using in our calculations is curl. Curl is a measure of flux through a vector field, and it'll tell you essentially the magnitude of turning, if you will, that's happening. As you can see, it looks pretty cool. It's kind of viscous and is like, I don't know, erupting or kind of like seething through. So I really like this texture. And what you'll see later is that each of these individual steps I pull out as output textures so that I can reference a bunch of different kind of intermediate layers of the fluid and get some cool effects that way. So curl is one layer. Divergence is another layer. Divergence is kind of, well, you can see the calculations here if you're interested. But divergence is another float that can be measured over a vector field. It's not specific to fluid simulations. You can measure this on any vector field. Pressure is another layer that we have. This is used less, frankly, because I find it has a lot of really hard lines, and I just don't really like the distribution as much. But those three layers are what the inputs to the actual solver are. The solver uses each of those as different calculation parameters to essentially perform advection on the velocity field and color field. So this is the good old gradient. We know lots of uses for that. It's probably the one that I use the most. Here, this is the advection color. That'll actually be the output. And the rest of this is a bunch of kind of input-output UI functionality that doesn't really matter that much. So that's an overview of the different layers, if not how the simulation's actually performing. And I just wanted to give a little bit of context because each of these is a different output layer. And so we can grab them and do a bunch of different things, and that can become pretty interesting. So on the input side, we have a color input, which takes a movie file in for our color input. That'll be the color that is sampled from and applied into the scene each frame. It takes a density input. White will emit. So the brighter the white, the brighter the emission. For example, if we make our softness less and our border width more, we can see that our emission is drastically higher. So that's emission, pretty helpful. I have a baseline velocity map that is these. So this is just kind of the default. There's actually some selection you can use for velocity. You can either use a terrain map, which I've talked about in other tutorials. You can use just normal simplex noise, or you can use curl noise. And well, we'll get into the parameters in a second, but each of those will have a little bit of a different effect. So we'll explore them more, but you can kind of see here already the curl noise looks a lot different from simplex. And the third input is if you wanted to put in your own, you could use this input to override the velocity with whatever your desired velocity field was. But you should definitely make sure to remember that it is in 8-bit float. In 32-bit float, because as you can see, changing that does wonders for my simulation. So if you're going to pass your own in, just make sure it's a 32-bit float. And you're probably going to want to make sure all of the inputs are 32-bit floats. One of the optimizations inside the simulation itself is making sure that the actual textures you're using, for example here, are only as many channels as needed. So here we're just doing 32-bit float RG. And we do that throughout the simulation. So the outputs, you'll notice, if we grab the gradient, for example, is just a 32-bit float RG. But the inputs should all be 32-bit float RGBA. So this is actually should be 32-bit float. And then our last input, I'll just copy and paste the circle, and we'll make it bigger. This last input is fun. It is the obstacle. And so if we reset, the obstacle will be exactly that, and will be an obstacle to contain your fluids. So there's a lot of fun that can be had here. You can make it bigger, make it smaller, a lot of different things. If you play with the softness and make it easier to see this, if you play with the softness, make it like a lot softer of an obstacle. And then also, I don't know, do something like multiply it by a low frequency noise or something like this. Probably minus though. Yeah, something like this. It can be kind of cool because especially if we make it thinner, you'll see that it can kind of start to like be burst through at points, which is kind of fun. Although it does need to be bigger than our input. So we can make this a little smaller, give us some more room. And yeah, now we can see we're kind of like pushing through the circle in different places. which can also lead to interesting effects. So that's the obstacle. So we have our inputs, then we have our outputs, which I'll label as just the color. Sure. We have our curl. We have our divergence. And we have our gradient. And lastly, we have our pressure. So this is the basic setup. So now we can look at parameters. So I have MIDI control set up, which means that I can control these parameters with my MIDI controller. It should be actually pretty easy for anyone to replicate. You just have to drop your MIDI here. I'm just selecting from mine in a different component, and then you just have to set up a chop execute like this, selecting the different MIDI channels and mapping them. Well, they're already mapped, so all you have to do is just really appropriately set up your MIDI receiver so that you can just replace this and point it at your MIDI in data stream. However, if you can't do that, I'll probably do a tutorial on that soon, actually, but probably not this week. Anyway, if you can't do that, you can just turn it off or delete them. It's fine. It will not, I'm going to turn it off now. It will not actually affect anything. Like if you have it on, you can see my one's tweaking right now. You can just turn it off and it'll be fine. You can always click and drag. So the parameters are output resolution, which for performance reasons, like if we look at this, it's taking, I don't know, about 3 milliseconds to cook. Let's look at this actually. Here we go. So let's work. Yeah, okay, so now we can monitor our GPU cook time on this guy. It's just another component I made. I'll leave it in here in case anyone is interested. So we're doing pretty well because this is like running at 2 milliseconds, 3 milliseconds. That's pretty good, generally speaking, for a 4K right now. But it is good to note that that texture resolution is going to apply to the color calculation and the advect color calculation. But these other textures and other calculation sizes are going to be simulation res. So I set the simulation res to 1024, and this res y is just aspect ratio corrected. So then you can change this to say Instagram, and our simulation y just works. The thing to know about, if I go maybe 1920 by 1080, the thing to know about simulation res is it's kind of like level of detail. So for example, if we do 128, you can see that things are moving a lot faster and the level of detail is a lot lower. It kind of looks like we're closer, more zoomed in, versus if I go 1280, one, it's slower and doesn't dissipate as quickly because there's more pixels to propagation to occur through, but it's also more detailed. And if I really zoom out, like 2500 maybe, it starts to get quite detailed. And we'll leave it this detailed. I mean, what's it running at now? Like 5 milliseconds, so about double. But we'll see the differences very soon. So here, the other parameters. This is color correction, so uncorrected is pretty gamma heavy, so you can correct using a variety of different color correction algorithms. These all just kind of work a little bit differently. Not all of them use this max loom, just the Reinhardt's, but it is a nice, pretty handy. I find myself using this Reinhardt extended loom and having the value right around here normally. But different settings for different things. Flow is going to be the amount of emit each frame. So by setting this to 0, you're basically just saying, okay, we're turning it off. As it goes up, more, and you can see that it gets very bright. Decay is pretty obvious. Decay is the opposite and will be how quickly things dissipate. You can see that if the flow is too high and the decay is maybe too low, or even if the decay is kind of high, you can kind of see the image. So you want to make sure that your flow is somewhat low, about as high as it can be before you kind of see the image behind it. And that will just make it look a lot cleaner. Passes are the number of iterations in our solver. So you can go up to 100 here, and the difference you'll see if I go to 1 and reset. With one iteration, our results are very flat, right? There's very little dimension because that solver is just running one time and giving us the results. But as we increase passes, we're adding iterations and we're getting finer details. Also more self-similarity because the details are being applied down. So you can go up to 100, like I said, and I actually do run around 100 a lot. I find the details are pretty helpful, but it does cost some performance. You can see now we're up around 11 milliseconds versus if we're at 10, one pressure pass, we're at 3 milliseconds. So especially with the higher simulation res, that's going to really hit things. Even if we just go up to 20, we're already at like 6. But if our simulation res is around 1250, then we're back down to 2, and we can run at 100 pressure passes and be at like 4 milliseconds, that is. So that's kind of the trade-off. Sometimes you'll really want the higher resolution velocity. I normally keep it somewhere around 1250, 1280, 1024, something like that. Output resolution hopefully can get pretty high. I generally do full HD or 4K. So color diffusion is kind of like decay, but is applied a little bit differently and is on another step. They work similarly, but decay is going to be more broad, and color diffusion is going to have less of an impact. So it's kind of like fine grain decay. Velocity diffusion will affect how much velocity dissipates throughout the fluid from the source. So if you get it pretty high, it'll definitely not really move too much, but it is pretty cool to mess around with, especially when there's more motion, because it'll result in this kind of like pushing, viscous looking thing. Next, velocity scale, pretty self-explanatory. Higher is faster. I never really go above 10, but somewhere down here, like in the 2 to 3 range, is normally good. Pressure is fun. Pressure and vorticity are both going to affect the quality of the curves. So if you go from 0 pressure to a bunch of pressure, you can see that the kind of pushing of the fluid throughout the volume is more dramatic. And so pressure is kind of that propagation. It affects how much velocity is transferred to neighboring nodes. And then vorticity is going to affect how many swirls and spirals and their level of detail appear. So higher vorticity is way more spirals, and like crazy shit going on, and lower vorticity is much flatter. So I find something like this is a nice balance, pressure around zero point 0.7, zero point 0.8, vorticity around 8 or 9, but again, all to taste. Pulse is just to reset, of course, and then as I mentioned, our different gradient patterns. So you can choose simplex noise. You can do an optical flow overlay, which means that if you have motion in your image incoming, like maybe if I animate this modulo 1. Yeah, so now I have some motion and it's kind of hard to see. But the motion is being read into an optical flow, and that optical flow is then being applied to the velocity input. So I have it turned down pretty low, but you can turn it up and then use the optical flow if you like. Velocity map translate is just to translate speed of the map, and then the period is the period of the map. So you can choose again terrain or curl, and each of them is going to have a slightly different effect. So that is kind of an overview of the component itself. As far as uses go, there's quite a lot. The one that I was going to show or had up earlier was using the gradient, and then this GLSL is a trick that I often do, and that is just normalizing. Just the RG components, remember, because this is just an RG texture. Just normalizing those with a quick one line normalize. And then to get us from 0 to 1, because these values can get kind of crazy, negative 75, 100, whatever, just whatever it is in the solver, because there's kind of like local space values. Normalize those for sure. And then we can pass them right into our pixel sort. And if you guys have been following along on that, all I really did to apply the fluid to the pixel sort was pass the gradient in as a velocity. This is right where I left off the last Pixel Sort 2 tutorial. I just cleaned up some of these components a little bit, but all the functionality is the same. So the only thing that I did to change the appearance was put this fluid in as the velocity here. And then I just turned the step size down. And that resulted in this really nice kind of fluidic, kind of morphing, I don't know, kind of reminds me of sea anemones. Sea anemones. Almost just kind of swaying in the ocean. And that's as simple as just dropping this component down, putting some source in, and then routing the GLSL through. But something interesting that you could do, for example, if we bring this maybe down here, would be if you take, instead of this color input, maybe we move the color. See here, we already have this feedback and this null. So what if I just drop the null on color by changing it to a select? And now oh, also want to change this to a select. Okay, what's going on here? Get rid of the obstacle. Get rid of this velocity map. Oh, well, that makes sense. Well, let's take a look at this then real quick. Let's drop that on for our emission source, and we'll just take the color out and have my default color in there. Okay, so here now we have our velocity. Things are looking a lot more reasonable. I'll put the color back out, turn this off. And now we should see the impact of our different velocities a lot better. So terrain, curl, you can see the gradient changing for these different things as well as our output. And then our simplex, also different gradient. Terrain, and then curl. Anyway, so I'm going to get rid of that. We have the density emit. Okay, so what I want to do is grab the output and use this as our color selection and also our density output. Now we probably need to turn the flow down a lot as well as our velocity scale down a lot and maybe our density up. Maybe our density, or sorry, not density, decay up. A lot more velocity map, go back to simplex. And now what we see is kind of a cool fluid over our particle, or sorry, our pixel sort, which is pretty fun. And by changing, maybe you can, brighten it up by turning this off, or by using this slider, make things a little bit brighter. And then we could even go so far as to put this into our other pixel sort image input. This is the one that we're putting into the simplified pixel sort in our other, down here. And then we have a much more complex output. And I'm just going to turn off some of these viewers so that we're not chewing up so much GPU while I'm also recording. I was working with some audio reactivity right before. Okay, so you can see my FPS is struggling. It is definitely not super easy, but I think that I should probably not be doing it in 4K and maybe I want it in just HD. Cool. So the spots, kind of like dark spots, are because we're pulling in this other image for our new pixel sort. And so if we drop down in here where our other pixel sort is happening, we can see that it's just kind of a moving image input. So we're sorting as the image develops, which honestly on its own actually looks pretty cool. So we might have to explore that too. But the spots are because of that. So you could potentially fix that by doing something like, I don't know, matting out the parts that are too dark with something like a chroma key. I don't know. And then if you like blur this and put it over the top, maybe that'll work. Like really blur it. And then you can do a matte of this over, I don't know, we can use our old input maybe. Oops, we can use our old input. This one we actually still want alpha. That works, but we want to switch the input so that we're getting just the brights where we need them. Okay, that actually worked pretty well. So yeah, what I did there was just recover the dark parts using a chroma key, and then I'm just using this matte to replace those dark parts with some bright parts from our other source image. And reminder, this is all just used in the 1 pixel sort, which is really high at the chain of waterfalls, which means its actual input isn't crazy, but it's just helpful not to have the black holes. Cool, so now we got some feedback going in as our color and our density. That's pretty cool because it also means that now our system is like a loop, a closed loop, which I always find brings a lot of very cool stuff. And that is also an example of another technique that I use a lot, which is using the same input for the density and emit, and then just kind of having this like fluid effect over the top. You can use this and then, for example, matte. If I just grab the color, and then I just grab the maybe raw output here, and then you can do something like a matte between these two based on, I don't know, maybe like a threshold of this, but maybe something like that. Yeah. Kind of blend it in, maybe not using the matte there, maybe use the cross here, and just bring in like a little bit, something like that. Just for like some highlights, and you know, you can probably do some post on this to make that look a little bit better. Turning like up the gamma and like down the brightness maybe. Yeah, that's looking better. And like, I don't know, maybe this is not what you're looking for, maybe not what I'm looking for today, but it's a handy trick to have because it's definitely what I'm looking for sometimes. What's another one that I use? I just copy and paste this fluid simulation. Just disconnect these wires. One other thing, I mean, it's pretty similar to what I just mentioned, but that is using a video as my input and output. And then you get this really cool like fluid over video effect that you can really dial in with the flow and decay parameters. Remember, because the flow high makes it look like the makes the video or texture appear behind it. So you can have the flow set like way higher than you normally would, and the decay set like pretty high. And then you kind of have this fluid trail something pretty cool effect. And so like a lot of times you can take this and then use this as an input to some other distortion and then comp that over the original video and do that in a way that is a fun effect. So those are two good ways. Oh, I guess another thing we can do is displace using the gradient. Again, you want to use a GLSL here and normalize this from and that should work. Normalize it so that we are between 0 and 1. Set us to red and green on the displace our source midpoint down to 0. Our displace weight down to 0 as well. And then we can turn our displace weight up and start to get this kind of cool other effect. Something else that can be interesting is doing something like crossing two fields and then maybe making like a velocity map out of two different ones, like this, let's say. And then using this reorder to, I don't know, this can also be a displace. You know, this is getting much crazier, even though our displace weight isn't actually that high. And that's because we are using some crazy values. We're using the curl crossed with a divergence and then sampling from the pressure. So this doesn't necessarily have like a relationship to the end result of the fluid. It's more like different internal layers being repurposed. But I find that it can be kind of awesome to use to get effects that are fluid-like, and you know, kind of evoke the similar types of dynamics that fluids have, but without being quite so obviously just like a fluid simulation. So that's another technique that I use a lot. So hopefully that is a good overview and some helpful examples for using this fluid simulation. It is my pleasure to share it. Like I said, it's been great for me, and I really hope that everybody can get some good explorations out of it. Show me what you got. And like I said at the beginning, thank you very much for all the support. It truly is meaning a ton as I'm trying to make this way more of my time. Your support is making that possible. So, appreciate it. Thank you guys a lot, and until next time.